Hello and welcome back, ladies and gentlemen, to the presentation. For the time being, I think this will be my final presentation, but this could change at any time, obviously. Maybe a month or so from now, I can make another one. But for the time being, this will be my final one. And it will be about object-oriented programming in Python. Um, Please let me know if you guys have any questions before the start of the session. And if there isn't any, I will get right into it. What is the issue that you're facing? If you would let me know. Okay, once you answer the question, I guess I will. I'll help you out. Just explain what is the issue that you're facing. Okay, let's get into object-oriented programming. Object-oriented programming in Python. So, what is object-oriented programming? It is a programming design that is structured around classes and objects. Classes are abstract concepts that represent real-life objects in code. Basically, what we're saying here is a class is basically a type of something. For example, let's say I have a car. You know, there's different types of cars. We have, let's say, Toyotas or Mercedes and that sort of thing. But they all share something similar. Like they all share having like four wheels, or they all have colors, and they all have a certain speed or horsepower or that sort of thing, right? So basically, what a class is, it allows you to represent these real objects, like cars, for example, in the code, and basically it's a template for creating these objects. Objects are instances of a class that each have their own copy of the class's attributes. So basically, like I said earlier, we have a Toyota, and it has all the attributes of a car. It has four wheels, it has a color, it has the horsepower, and that sort of thing. These objects can also interact with other objects of the same or other class using methods. And these objects pass data between each other using parameters. So what a method is, it is a sort of a function that is like basically within the class. It's nested in the class, and these functions, they allow you to pass data between the objects or modify the attributes of the object. And these things can be done using parameters. These are variables that you pass into the function. These are the variables that you give to the function to help it out with its task. Let me just check if there's any questions. No questions so far. Okay, I'll continue. So here is sort of a diagram explaining what I'm trying to say. So we have a class here. It's basically like a template of some kind, and what we can create several different objects from that template. As you can see, the template has a name and a size. And each of these objects, they all have a name and they have a size. So for example, here this one is object 1, and it's of size 2, and object 2 of size 3, and object 3 of size 1. As you can see down here, it says each object has its own value for fields and can call the methods found in the class. These methods are things that help us, like I said earlier, with modifying and passing data between the objects. And as you can see here, they don't have to be the same. They can have different variables or different, what do you call them, values for these variables. Okay, let's move forward. Classes and objects. Classes are defined by the class keyword. Methods are defined by the def keyword. And class methods are nested within the class. So you can see here in this diagram, we have an example of a class. And this one is called test class. Let's see. Oh, I've been receiving this error on the choreograph app. This one. Hello? Can everyone hear me again? I'm having some technical difficulties. Okay. Anyways, this error, I think you can solve it by just there's a certain library that you can get. Let me just check quickly if it's available. Let me see. It's one of those Microsoft Trade distributables. You can download them. Microsoft Visual Studio C++ 2010. If you download this one, and you'll be able to, fix that problem, I think. I have never had this issue before, but this should fix it. Did you get that? Okay, let's get back into the presentation. Okay, yes, let's continue. Now we have the init constructor. Basically, this is an initializer, and almost all object-oriented programming languages, they have a constructor, and it makes instances of a class. So, for example, we said earlier that we have objects that's from a class, and we need a way to create them. So this is what the constructor is used for. This thing is called by using the name of the class as a method. So if you want to call it, you use the name of the class. So in our case, if we use test class as a name, we do variable equal test class, the parentheses, and whatever parameters it needs. Variables can be input into the constructor using parameters. So let's say I want to create a car with a color blue and 3 wheels, for example. So I would call the class, test class, and then I'll put in brackets the color, which is blue, and the number of wheels, which is 3. Okay, let's get into the Visual Studio part of this, so I can show you the code. Wait, the download 2013 version. Try downloading 2010, because I think it was a different era from 2013. Okay, let's get back into the lecture. Let me just switch to the VS Code. Okay, hopefully you guys can see my screen now. So let's create first, before we start, let's start with a method. So if you want to create a method, you do def and then the name of the method. So I'm going to call it method1. And we're going to have these little parentheses, and inside it are all of the parameters that we will be passing into the method when we want to call the method. So let's say I want to pass in a number. So I'm going to put in a variable called number. And of course, if you want to create a function, you'll be needing to use these colons. You can see here. And click enter. And let's create some code in here. Let's say I want to print this number here. So what I can do is I can write print and number. As you can see, what this function will do is it will print this specific number that we input inside the function. So if we run this code at the start, you'll see nothing happens, all right? Because we defined the method, but we didn't actually do anything with it. We didn't call it. So let's quickly call this method. If you want to call a method, you need to use the exact same name, which is method. And in parentheses, you put in whatever parameters you have. So I'm going to input the number 5. So let's see what happens now. As you can see, it prints the number that we put here. Of course, it doesn't have to just print. You can put in any code in here, and you can make it run that code. Let me see if there's any questions. Nothing there. Perfect. Okay. Now let's start with the class. So when you want to create a class, you just write class and name of the class, which I will be using test class in here. And then you just put in colon. That's it. So that's how you create a class. And now let's define let's define some functions. I'm going to have a First, the constructor. That's the most important function in a class, because if you do not have a constructor, then the class is quite useless. So I'm going to write init, and I'm going to have the keyword self. What this self does is, this is present in all instance methods. An instance method is a method that is, what do you call it? It is called on an object or an instance of a class. So basically, we have different types. We have an instance method and we have a class method. A class method is only called on the class itself. You don't call it on an object of some kind. So what this means is the class it doesn't have like attributes of the what do you call it, the object itself. It cannot call those. So we need to include self for the instance methods to work just fine. So we include self, then we include whatever parameters we want. In my case, I'm going to have two parameters, and I'm going to call them attribute 1 and attribute 2. So you put in the parameters here, a1 and a2. Then we put in the colon, because that's how a lot of things in Python work. And then what we're going to do is we're going to use self dot. What self dot does is, this basically makes it so that this attribute is an attribute of the object. Because if you don't put self, then it will not work. It will just be some random variable that you don't really need. So you need to attach this variable to the object using self. And then we can put any name we want. I'm going to put underscore attribute 1 equal to a1. So what we're doing is we created this new instance variable, self_underscore attribute 1. And we're assigning this parameter that we get from calling the constructor, and we're assigning it to this object here. This variable here. Why did I use this underscore here? It's because I'm going to be talking about this later. It's something to do with encapsulation. I'll be discussing this later. Now let's create another variable. I'm going to call it attribute 2. So self_underscore attribute 2. I'm going to call it equal to a2. So I'm assigning this a2 here to attribute 2. And that should be done. So now we can create an object of type test class, and it has two attributes, attribute 1 and attribute 2. Let me check if there's any questions. Nothing much. Perfect. Okay, let's get back into it. So now let's define a method. I'm going to be using a getter method. What a getter method is, it basically returns one of these values here. So let's say I want to get attribute 1. What I do is I'm going to create this method here, get a1. And of course, you need to include self because it is an instance method. It needs to interact with an object. So if you want to get something, you have to return it using the return statement. And if you want to return a specific thing, you just return it like this. Return and the name of the variable that you want to return. So this is how you can get a value out of here. Now let's create a setter method. What a setter method does is it modifies one of these variables. It doesn't just get it, it modifies it. So let's define a new one, def set a1. Of course, you also include self, but if you want to modify a variable, you need a new variable to take its place. A new value to take its place. So let's say I'm going to put value here. You need to have another parameter. So, like up here, you see, you're passing this new value inside to this object. So what we do is we take the one we want to modify, which is this one here. We want to modify this and make it equal to the new value. As you can see here, these are equal. Question? You didn't get the underscore thing. Okay, the underscore thing. What happens with this is it's a thing called encapsulation. I'll be discussing it later. You don't have to worry about it for now. do a recap on the class thing. Okay. What a class is, it is a type of, it's basically trying to represent a real-world object inside code. So let's say I want to represent a car. You can't really make a car in code unless you use a class. So we can define a class called car, and then we can create attributes for this car using this here in the initializer. You can create, let's say, wheels, you can add the color, you can add that sort of thing, but I'm just trying to make it general here. Hopefully that makes sense. Please let me know if I answered your question. I'll move on until you answer your question. Okay. So after doing the getter and the setter method, we need to create a class method. So I can show you the differences. If you want to create a class method, you what do you call it? It's just like any other method. You can give it any name you want. I'm going to call it class method. These are all just random names, and you can give them any name you want, but for the sake of simplicity, I'm just going to call it get and set, and in this case, class method. What's different about a class method is you don't really need to use self, this one here. You don't put it in here because you're not going to be interacting with a specific object. You're only going to make a general function that is within this class. So I'm going to be printing let's say this is a class method. So this is just a general thing. And I'll show you how you interact with these objects just now. This should be everything for the time being. Perfect. So now let's create a function outside. You see, in programming, it is good. It's good practice to what do you call it? It's good practice to create a main function. This main function calls the classes, it calls the other functions and that sort of thing. So we're gonna define and make sure this is outside of the class. You see, these are all indented inside the class. This. But this one is outside it. Look, it's indented outside. So it does not follow this class. It's a separate function on its own. Make sure you have this in mind. So I'm gonna call it main, and I'm going to define something inside it. So I'm going to first make an object. I'm going to call it obj1. And if you want to create an object of this class, you take the name of the class, test class, and you put in the attributes you want. So I have attribute 1 and attribute 2. So let's say I want my first attribute to be name, and my second attribute to be age. So this is what you do. All parameters, right? They are separated by the comma. So this is A1 and this is A2. Of course, if you have many more, let's say A3, A4, and etc., then you'd include more of these when you create it. So what I'm gonna do now is I'm gonna get the first one. So I'm gonna print it first. I'm gonna print, and I'm gonna call obj1. obj1 dot. So this is how you call a method on an object. You take the name of the object, then dot, then the name of the class, which in this case I'm going to use is get a1. Of course, if it's a function, you always include parentheses right after. So we have print obj1 dot get a1. So this is going to get this name and it's going to print it. Then I'm going to do a set function, which is obj1 dot set a1. And of course, we have the parentheses, and I need to put in a value that I'm going to change name into. I'm going to change it into full name. And then I'm going to print it again. So you can see that there's a difference. And finally, since we defined the main function, we have to call it. You can't really define a function without calling it. So at the end here, I'm going to call main. So you can see here, we have the class. We defined the class. Then we defined a main function that does all of what we needed to do, which is obj1. Then you create an object. You print the first attribute. Then you're going to change the first attribute into full name. Then you print it again to see the changes. And then you call that method that you defined. Let's see what happens. As you can see, at the start, it called it. It created the object. It retrieved the attribute from this object and printed it. As you can see, name, same here. And then we changed it. We got to the object. We changed the name to something else, which is full name. And then we printed that object again, as you can see, full name. Of course, these are very simple, and you can make them as complex as you want. You're only limited by your imagination. Let's see if there's any questions. Is self fixed, or can we use other names? Self is fixed. You're not supposed to use any other names. Just use self, and everything will work just fine. Hopefully, I answered your question. Now we can switch back to the presentations. Okay, so let's discuss encapsulation. To answer your question, encapsulation basically, all methods and variables are public in Python for the sake of simplicity. In other languages, you can define if a variable is reachable by other objects or other things. So, for example, like in Java, for example, we have 3 types of encapsulation. We have 3 types of variable transparency. Sorry, not encapsulation. We have public, we have private, and we have protected. But in Python, because the creator, he wanted to make it simple. So what he did is he made all variables public, all methods public, which means that any object or any function can access any other object's attributes. It doesn't get blocked. And there really is no way to change this. So what programmers started doing is, by standard, they started adding this one here, underscore, before any methods or variables that they want to be private, that they want to be hidden from the user. It doesn't actually change anything. It's just good programming practice, so that when other programmers, they see your code, they understand what you're trying to do. Hopefully that answers your question from earlier. Okay, now let's move on to class versus instance. Like I said, when I was discussing the code, we have 2 types of methods and variables. We have a class and we have the instance type. Class methods, they are called via the class. Basically, if you want to call a class method, you do class name dot, and you call that method or the variable. And if you want to create an instance method, and these are, if you want to call them, they are called via the instance or via the object. And it makes sense that a class method, it cannot access these instance variables of a specific object, because when you're calling a class method, you're calling it generally, you're calling it on the class itself. So it does not know that there are objects out there. It does not have access to the objects themselves. It does not have access to the attributes. So that's why a class method cannot access instance variables. But an instance method, it can do the opposite. It can access class variables. So what is a class variable? A class variable it's a variable that can be accessed by any object or any function, right? As long as it's public, of course. It is defined above the function. I'll be showing this in code in a little bit after I just explained it. It's defined above the function on the same level. And any object can interact with it. They're usually used for constants and that sort of thing. For example, I want to have a constant of 20. And I don't want that to change. So I can, define a class variable called constant and make its value equal to 20. So here is an example of something. As you can see, this is a class variable up here. This class variable is defined on the same, or like slightly above the initializer here. That's just good programming practice. You can do it anywhere, of course, but it's good programming practice to do it at the top. And you can see they're on the same indentation level as the function itself. it's not inside the initializer like the instance variables. As you can see, here's a difference. And also, another thing you can see, a class variable does not have the self attribute attached to it. It's just a class variable, so you can name it anything you want without self. It's not attached to a specific object. As you can see here, this is an instance method because it has self in it, and this is a class method, and this one does not have self, so does not have access to the object. And as you can see down here in the main area, we have an object. That what do you call it? It's calling an instance method, and the only way to call an instance method is to call it through an object. And as you can see under that, we have a class method, and this is being called through the name of the class itself. As you can see, the name of the class is test class dot name of the method. So that's the difference between a class and an instance variable or instance method. Let's check if there's any questions. So underscore variables are still public. Yes, they still are public and you can still access them, but it's just good programming practice to avoid anything that has an underscore. What init means? Init is an initializer or a constructor. Like I said earlier, it helps you create an object. Because if you do not have an init or an initializer inside a class, you really cannot create any objects. And if you cannot really create any objects, basically it's useless. You can't really do much with the class if you cannot create objects. Like I said, it allows you to create instances of the class. Hopefully that answers your question. Okay, let's move on. Useful methods. Okay, we have, I already discussed a few of these already. We have, what do you call them? Useful examples of methods. The first one is the constructor or the initializer, or like I call it init. It helps you create instances of a class. Then we have getter methods. I mentioned this when I was coding. It returns an instance variable using a return statement. I already showed this, and yeah, basically what it does is if you want to access a certain attribute, you use a getter method. And we have a mutator or a set method. Mutator and set, they are the same thing in this context. So what a mutator or a set method does, it makes changes to the instance variable. So if you want, you can increment it, you can multiply, you can subtract, you can divide, you can completely change the value of the variable itself by just passing in a new variable like I showed you. And finally, we have the class method, which is useful for returning class variables. Like, for example, like I said earlier, it is used for constants. Okay, now let's discuss this new concept called inheritance. So, something special about these classes is you can have a class that is sort of like it copies another class and then adds onto it. That's what inheritance is. You're inheriting a class. What you're doing is you're copying all of the instance and class and methods and that sort of thing, and you're copying them in this inherited function. And what this does is, like, let's take an example. I'm going to create a class called vehicle, right? And vehicle, it's very general. A vehicle, it takes you from point A to point B, and for example, it has wheels, or it has color, it has a name, and that sort of thing. But what if I want something more specific? What if I want to create different types of vehicles? I want to create a car, I want to create an airplane, I want to create a train, right? So what I can do is I can create a new class that inherits from this vehicle class. So I can create a car and make it inherit all of the elements, all of the instance variables, all of the class methods from that, from that vehicle class. And we're going to call it, in this case, a superclass. A superclass has inherited classes under it. It has stuff inheriting from it. That's what you call a superclass. And when a class inherits from some other superclass, it is called a subclass. Okay, let's read the notes. Inheritance is the ability for a class to extend or inherit features from another class. So let's say, the inheriting class is called a subclass, and all of the variables and methods, both instances in class, are inherited in the subclass. Inheritance is done with the following syntax. In Python, you write the name of the class, you write the keyword class, then the name of the subclass, and in parentheses, you put in the name of the superclass, the class you're inheriting from. Inheriting classes can override methods by using the same name, and inheriting classes can add their own methods and variables. I'll discuss this just now. Let me just check if there's any questions. Self is the name of the function, while A1 to add the variable inside self. Self is not the name of the function. It is the name of the object. Self gets replaced by the name of the object by the Python compiler. But I guess it's sort of a similar idea to what you're saying. Okay, now let me just talk a little bit more about what do you call it? Adding their own methods and variables. So obviously, when you inherit, you want to add more features. For example, when you inherit vehicle and you create a car, you want to add more features to it, like, for example, horsepower or other things that are not present in a general vehicle but are present in a car. You're trying to make it more specific. And let's see. Let's discuss overriding now. Overriding. So, overriding. What happens is you can have in the subclass and the superclass, you can have the same name for the method, exact same name and no changes, right? So what happens? What the compiler does? The compiler first checks if the method is available in the object class. So let's say I have an object 1 and I'm calling get a1. I first check in the subclass, is get a1 present? Is there a function called get a1? If that's present, then it's going to get called and the program will write like normal. If it's not present though, it will check if this class has any superclasses. And if it does, it will go to that superclass and then check in that superclass if there's a get method. And if it's there, of course, it will call it. And otherwise, it's going to keep going up and up and up through the superclass hierarchy. You have to understand that a superclass, it can have multiple subclasses and it can have multiple superclasses as well. It's just a bunch of classes inheriting from each other. So the compiler is going to go through all of these subclasses or superclasses until it reaches the end, and until it finds something. Okay, a self like this in other languages. This in Java, I think you're talking about Java, right? This is, what do you call it? It's not really the same. Because this, no, not really. I don't think they're that similar, because this is only used when you use, I think, variables. That's what I used it when I did Java. I only used this when I was trying to take in parameters and assign them to a variable of the same name as the parameter. That's whenever I used it. And I don't think they're very similar. Like they kind of are, but not really. JavaScript. I haven't really used JavaScript, so I'm not exactly very sure. But I have used Java, and that's what I used this what do you call it? This keyword in for. Hopefully that answers your question. Okay. Okay, finally, the overridden method can be called using super. So for example, let's say I have a get a1 in a subclass, but I also want to call the get a1 in the superclass. Like I still want to keep that functionality and add on to it. So what I can do is use the super modifier, super in parentheses, and that's what happens. That's what it does. Okay, here's the diagram. As you can see, you don't need to see it for now because I'm just gonna write the code myself. And finally, we have an underscore string method. This is sort of like, let's say if you're using another language, it converts the object to a string. It's a special method that returns a string when an object is printed or a string version of it is required. And what people usually use the str method for, what they usually use it for is, what do you call it? When they want to return information about the object. For example, I want to, let's say for a human, right, I want to include the name, the age, the height, the gender, and that sort of thing. And then you print them in the form of a string. So that if let's say a print function, right, it's trying to print an object. Usually you can't really print an object, it doesn't really make sense, but if you define the str method, then you will be allowed to print an object. Okay, that should be it for the slides. Okay. Can a subclass inherit the properties of more than one superclass? Yes. If you want, you can have, like, what do you mean by more than one? Do you mean two different superclasses or superclasses that are actually subclasses of each other? What do you mean here? Because if you want to have two completely different classes, then no, you cannot inherit from both at the same time. But if you have two classes that are already inheriting from each other, and you add this other subclass to the hierarchy right under them, so you can have like three classes inheriting from each other, then yes, you can do that. But you cannot have two completely different unrelated classes and inherit from both of them at the same time. You cannot do that. Hopefully that answers your question. For the forum, which session should we choose since session 4 is not there? Okay, that should answer your question. Okay, now let's move into VS Code. Okay, so we have this class already, like I showed earlier, and now I want to create a new class. So what I'm gonna do is I'm gonna go to the end of this class and create a new class here. I'm gonna call it class. I'm gonna call it subclass. So it's easier to tell what it is. So if you want to inherit from a superclass, you need to include its name in parentheses. So here I'm gonna put the name of the test class, and then we put this one here. You can see the colon. Then you click on enter, and if you, of course, since this is a completely different class of its own, and it's inheriting stuff, you also need to have, it needs to have its own, what do you call it? It needs to have its own initializer or constructor. So of course we need to define a constructor. Okay, when I did the site, Visual Studio Code is very smart. It detected that this is a subclass of test class. So what it did, it completed the initializer for me, and immediately it called the super initializer, and it gave it the parameters. So what this is doing is, right, what's happening is, when the constructor of subclass is called, what it does is, it's going to get called here. It has these parameters, and at the start, before it does anything else, it calls the super, as you can see here, the super initializer, and it basically calls this one. It calls this one, and it creates these attributes, as you can see here, using these ones here, A1 and A2. And let's see if there's any questions about that. Nothing? Perfect. I'm going to repeat one more time. In the initializer of the subclass, you put in the parameters, and then immediately before you do anything, you have to call the superclass initializer. You have to call it using super parentheses dot underscore init, which is basically the initializer, and you put in whatever that initializer needs. As you can see, it needs A1 and A2. You ignore self when you call, what do you call? When you call a function, you don't really need to include self. but when you define it, you need to include self. So we're calling the initializer from the superclass, and let's say I want to add something else. So I'm going to add a thigh, and right under after I'm done calling the superclass, I'm going to create a new one called self dot underscore attribute. Okay, let's call it extend attribute. Extend attribute 1. I'm going to make it equal to a thigh. So what happens here, the super initializer is called, the superclass 1. It creates attribute 1 and attribute 2, so we don't have to really write that code again. And then we create our extra one, which is extend attribute 1, which is, in this case, a thigh. So now let's define a, what do you call it? Yeah, sure. I guess we can just create, let's create an object here. You know, actually, let's define a string method. Okay. Okay, let's go into it. Def underscore str underscore, and then we include self. So let's do this for the time being so it doesn't cause any issues. Okay, I'm going to create a string method inside the original class, so I can use it as a demonstration. So what we need to return is a string, and I want to return all of these attributes here. So what I'm going to do is quickly do this. I'm going to do attribute 1, and I concatenate self dot underscore attribute 1 plus attribute 2, and then plus self dot underscore attribute 2. So you can see here, I'm basically returning what do you call it? A string containing all of my attributes that are in my class. I have 2. As you can see here, I have 2 of these. So I'm just going to do this. I'm going to return attribute 1, and I'm going to return attribute 2. All of these are in a string. So when I return it this way, what's going to happen is these two are going to combine, and it will look quite ugly, right? Because they're all going to be on the same line. So I'm going to include this special character here. You can see this. You can see it's a backslash n. It basically creates a next line so that it will look nice. It will make it nicely formatted. Okay, no questions. Perfect. Nice. So now we created this string. Basically, what happens is whenever we print our object, is going to return this thing here. So let's quickly just print it. Print obj1. As you can see, it printed the attributes. It printed name and it printed age. Now let's define that same string method, but let's define it inside the subclass. Def string self, and what we're going to do is we're going to call the super version of underscore string, and we're going to add a new attribute to it. We're going to call it attribute type, and we're going to add self dot underscore extend attribute. So what we did here is we called the superclass string method. So we're calling this one, and we're getting this string here. We get the string for the first 2 attributes. Then once we get it, it will replace this area here, and we're going to add more to it. We're going to add. Let's see. Of course, I need to add return here. I'm going to add more to it, which in this case is attribute 3. So self.extend attribute 1. Now I'm going to create a new object, object 2, of type extend class. Wait, subclass, sorry, that's the name of the subclass. And I'm going to put in name, age, and I'm going to add the attribute type. Let's say I want height as my third attribute. And now I print object 2. So as you can see here, let's see, print name, age, return plus attribute type extend. Oh yeah, of course. We need to add this one here so it can make it look nice. So now we created a new object. As you can see, it has name, age, and height. And we didn't have to include name and age, right? We didn't have to include them in the subclass. It just calls the superclass, and it does all of that work for us. And of course, this is why inheriting is so powerful. You don't have to keep writing the same code over and over again for things that are in common. You just inherit them. And as you can see how small the code, what do you call it? The code for this one, for the subclass is, because you're only adding extra functionality. And as you can see, if you want, you could call a get method from the superclass on the subclass. So object2.get a1. As you can see, in the subclass, we don't have a get a1. But then if you go on top in the superclass, we have a get a1. And it will work just fine. Let's run it. See, it prints it. It prints the name. Let's just change it to show that it's different. Look, it prints the name. So you don't have to define the same thing over and over again. You can reuse it by inheriting. That should be it for the lecture for the time being. Wait, the underscore attribute, I should name it with the underscore. Which one? Which one exactly? Are you talking about extend attribute? Hello? Are you still in the... Okay, yes. See, for any variable that you want to keep private or you expect to be private, you put the, what do you call it, underscore. You can put the underscore for methods as well. For example, if you want a method that you're not supposed to use outside of the class itself, you could also put an underscore in front of that method as well. Usually variables, instance variables, they're usually supposed to be private. You're not supposed to interact with them directly. And this is why in all of my examples, I put this underscore. The first one, which is the first one? For this one here? Yeah, these attributes, they also need to have, what do you call them? The underscores, because I expect them to be private. That's why I include the underscore. Does that answer your question? Also, everyone else, if you guys have any other questions, please feel free to ask them, because this is the end of the session, and yeah. So it makes it constant. What do you mean it makes it constant? Are you trying to make, if you want to make a constant, you're going to have to make it appear. Constant equal to, let's say, 20, for example. This is where you can define your class variables or constants. You define them on the same level as the functions, not inside the initializer. And since they are a class variable, you don't need to include self or that sort of thing. You could, if you want, you could also include an underscore to show that this is a private constant that only the objects can access, or you could just leave it without it, so that let's say if you want an object outside of this class, it can call this constant. You can't change. You can change it later. You know, if you want to, for example, let's say like you can edit the code later, of course. If you want to make it public, you can just remove the underscore. But of course, you're going to have to remove the underscore from all the references to that variable. You know, you have to change everything if you want to change that specific one. So it's best to have in mind what type of variable you want. Like if you want it to be public, you make it public from the start. Okay. Any other questions, everybody? Please link of WhatsApp. I'm not sure what group you're talking about. Any other questions? There doesn't seem to be any questions. So, okay, I guess that's the end of the session. Thank you guys so much for coming to these presentations. Wait, no. Isn't the definition of a class variable and constant the same? Not all class variables have to be constant. Like, they usually are used for a constant, but they don't have to be. If you want, you could write a class method that can, like for example here, I can make this class method, I can make constant equal to 12 instead of 20. And whenever you call this class method, it will change this constant. Like it's usually used for constants, but it doesn't have to be constant. It could change. But it's usually used for constants. But aren't they declared in the same way? Yeah, they're both class variables. So you can just define them here. You can define them on the same level as a function. Like constants are not a special subtype of their own. They are just class variables. Constants are just class variables. They're not really separate things. You don't need to distinguish between them because they are. I think I might have worded myself incorrectly. They're the same thing. Like, okay, cool, nice. Any other questions, everyone? Okay, I'm gonna have to call it a day for now because it's getting a bit late. So thank you guys so much for attending these presentations, and of course, make sure to fill out that form so you can get some sort of certificate. Okay, thank you so much for attending and have a good day. Bye-bye.